Hey everybody, this is Selenium Tips and Tricks. It's a culmination of uh, tips that I've written about converted from previous languages like Ruby over to Java. And if you're new to Selenium, this might not be for you. There's some potentially more advanced and intermediate concepts in here. For people who are at that skill level, I encourage you to check out some things that I have, which are available, like the Selenium Bootcamp, which is a 5-part email course, a 5-day email course that teaches you just enough to get started with using Selenium successfully. And there's also the Selenium Guidebook, which is effectively a self-paced training course that I put together, which teaches you everything you need to know in order to get started with Selenium, even if you have no programming background, and to work your way up to a reasonably fully scaled suite of Selenium tests that are well factored, easy to maintain, and robust, and working with continuous integration and a whole bunch of other cool things. So it's worth checking out. These resources are currently both available for Ruby and Java. I'm actually in the process right now of converting them all over to all of the official supported programming languages for Selenium, so C#, Python, and JavaScript. So those will be coming soon. And also, I every week publish a tip on how to use Selenium successfully. That's where this presentation came from. And so at each of these links, you could check out all of those resources. And speaking of the weekly tips, elementalselenium.com, that's the website, and you can see all the Ruby tips there and sign up for either the Ruby or Java weekly email there. And then all the examples I use for these tips come from this open source web app that I built called The Internet, and it's available at that link there. And there's, I think, almost 40 different examples which demonstrate functionality on the web. Some functionality that's either just very common or just an example of a poorly designed app versus a good designed piece of functionality with semantic markup. So there's going to be, I believe, about 13, maybe 14 different tips I'm going to step through. And the first one we're going to start with is headless testing, which is one of the most popular and prominent topics of everything I've written about. And so the benefits of headless testing and kind of what it is. So headless testing is where you can run your tests without a browser effectively, or without really a graphical user interface for the browser. And there's a couple different ways to go about this. But the benefits of it are that it's typically faster, depending on the approach that you use, faster than using a full browser. And then there's potentially less maintenance because it's just a headless browser. You're not maintaining a grid and those kinds of things. And then it's just like every other browser. It does give you the option to do screenshotting. So if there's a failure, you can screenshot. And if you're curious about what headless browsers are available, here's a link to a list that someone's keeping for all available headless browsers that exist. It's very comprehensive. So one of the first ways that you can set up and do headless browser testing is from tip 38, which I've written about, which is using something called XVFB. And for those of you that don't know what XVFB is, it's short for X Virtual Frame Buffer, and basically it's for Linux or Unix-based systems, and it's basically an in-memory display. So you can launch a full browser in a virtual frame buffer. So essentially, you're launching a full browser, but you don't need an actual display port for it to effectively work. Like, you don't have to have a monitor connected to the machine just to have it run. So it's great for CI servers. And if you're running a small suite of tests, like on a CI server, then you're all set. That's pretty much it. It's a good way to get started quickly without actually stepping into the high stakes of potentially running your own grid or reaching for a third-party provider. So a couple options for running it. You obviously have to install the binary for XVFB. It's an actual app. But once you do, you have to start it on a specific display port, specifying an actual virtual display port, and then background the process. And then you have to tell the terminal session that you're using what the display port is that you just set for XVFB to use, and then launch your tests. And since you when launching XVFB told a display port and then told the terminal that was the display port, the tests will launch the browser and that browser will be running in that DisplayPort. And then this approach, of course, will keep the XVFB executable running in the background until you kill that process. And then the second option, there's actually a separate binary executor called xvfb-run. And what that does is it'll actually spin up xvfb, find and open DisplayPort, and then run the tests. And then once the session ends, it'll actually kill the xvfb session. And then there's no DisplayPort declaration necessary with this approach. A couple of notes about this. There is a potential for DisplayPort collisions if you have a lot of different jobs running on a CI server that are using XVFB. So you want to find a way to use unique values to actually launch XVFB. And one example would be pulling the build number for the CI and using that as the DisplayPort number. Alternatively, what you could do is when running concurrent builds, you could actually use xvfb-run with a runtime flag of -a to avoid this issue. And then this kind of wall of text is from the actual long form write-up for that link at the beginning of the section. Basically, that's the gist. When running concurrent builds, avoid collisions, and you can do something like this. That's one way to do it. An alternative headless execution path, which is typically more popular, is using what's called Ghost Driver. And Ghost Driver is actually built into what's called Phantom.js. And Phantom.js is a full stack web browser. It gives you JavaScript execution without actually launching a GUI. And you basically go to this website and you have to download it. And then after that, you can use it. And there's support for it built into the Selenium project. That's what Ghost Driver is. So why use it? You get faster execution times. You also have the use of CI, just like with XVFB. The additional advantage here is that it's not limited to just Linux. It works on every platform. So option one for using Ghost Driver and Phantom.js, you of course have to download the binary. And then you can start Phantom.js directly using the -- WebDriver flag, and you have to specify a port that's available when you do this. And that just starts up the Phantom.js server. And then you can connect your test to this Phantom.js instance using Selenium Remote. And alternatively, you could actually use this approach and connect Phantom.js to a Selenium grid if you wanted to do that as well. And at that link is the documentation for how to do that. And for the actual setup code, it looks like this in Java. So you have to create a desired capabilities object, which is what Selenium Remote needs in order to understand what kind of browser you need, what kind of operating system, etc. And then we set the browser name to Phantom.js. And then we connect to the local host on the port we specified and pass in the capabilities object. And then that gives us back a Phantom.js instance. And then it's just like using any other browser. Option two. Again, download Phantom.js, and then you have to tell Selenium where this binary is on your local file system. And then you can launch Selenium with Phantom.js, just like you would Firefox, for instance, or Chrome. And that looks like this. One approach, instead of adding this binary to your path or putting it somewhere random, you can actually include it in your project. And that's typically how I do it. I create a vendor directory and then place third-party things like this here. And then in the code itself, you have to set a property. And the property that Phantom.js is looking for is called phantomjs.binary.path. And by getting the user.dir property, we can make this, we can create a relative lookup for this project directory and then specify the remainder of it, which is /vendor/ everything to get to the actual Phantom.js binary. After that, it's just driver equals new Phantom.js driver. And then just like before, we'd get a Phantom.js browser instance. Next is visual testing. And I put this in the front because it's gaining a lot more popularity, just like with headless testing. And also, I've spent a lot of time thinking and reading about it. And I really feel like it's the one thing that everybody should be paying attention to and considering doing in their testing practice. So just for a quick primer of what it is, it's the ability to check an application's UI so that you can determine with automation that it appears correctly. This is the kind of thing that used to be and is still thought that it can only be accomplished to test this kind of thing manually, look and feel. Like it's really hard to do really reliably with a computer. But with a lot of the advances in automated visual testing, that stuff's pretty well solved. I mean, there's still false positives and pros and cons, but these are all workable challenges. But as long as you know what they are. So you can also use it to verify complex content, things like charts and graphs, and basically anything that has some sort of really elaborate look and feel to it that would be really hard to use traditional automation to verify, just by doing element lookups and things like that. And the real kicker here is that you get hundreds of assertions for just a few lines of code, because it's checking so many different things of what's on the screen, that to do the equivalent with traditional assertions in Selenium, or just relying on a human to look at it, there's going to be things that humans will miss, and that we can use a computer to do what it's good at. So some of the challenges that are inherent with visual testing, there is complexity you have to manage. There's all the different viewport sizes, in addition to if you're dealing with like responsive device testing or mobile, you need to start thinking about real devices versus simulators, emulators, and the list goes on. So it's more than just the standard challenges for desktop browsing. And then there are false positives, like I mentioned. Most every automated visual checking tool uses what's called baseline image comparison, where it takes an initial snapshot of a page, and then it uses that snapshot to compare it to future snapshots. So you rerun the test, another snapshot is taken compared to the previous one, and it's this comparison that can lead to false positives, how these libraries actually do this check. So things that could potentially cause visual tests to trip up are shifting content, dynamic content. Shifting content as in like an element appearing out of place slightly. Dynamic content like a news website where headlines always change every day, but the layout stays the same. And even typos. You could potentially miss typos. Typos could potentially cause things to fail. So these are all challenges. As I said, if you know the challenges, you can actually find workable solutions. But I'll just skip ahead through there. I'll skip ahead to a better solution. Just you could use Applitools Eyes, which is a tremendous provider for automated visual testing, and Sauce Labs. You can take your existing tests, point them at these services, get any browser and devices you need, and take snapshots and do baseline image comparison with some real crazy good intelligence. So for Applitools Eyes, there's a simple SDK that you would put into your POM XML, like this. And then once you do that, you can take this existing test. This is just a really simple rudimentary login test from the internet, where it loads a login form page, fills in the form, submits the form, and then asserts that this success message has appeared on the screen. So what we can do is update the setup. So we first have to import the Eyes SDK class, and then we want to create a field variable so we can use the Eyes object in our test, as well as in our setup and teardown. And then in setup, we take our Firefox instantiation for local execution, and we store it in a new local variable called browser, and then create an instance of Eyes by providing the API key, and then we call eyes.open and then pass it the local browser instance that we just stored, along with some metadata for the test, so like the name of the app and the name of the test. And then this will return back a slightly modified driver object. So we'll basically be running tests locally on Firefox, but the Applitools Eyes platform will be able to take snapshots when we ask it to, so it can create baseline images for comparison. And then in our test and in our teardown, we have to make a couple of tweaks. So we need to call eyes.checkWindow. This is what is telling Eyes to take a snapshot. So we go to the login page, take a snapshot. We can provide metadata or not. That's optional. So for this case, this is the login page, so I'm just going to call it login. And then after logging in, I'm going to take one called logged in. And then I call eyes.close. And this is what triggers the comparison against the baseline image. And then in case there was a failure, if there were, it would raise an exception with a link to the job in the Eyes platform to review. So if that happens, we want to make sure that we actually abort the session if it wasn't closed properly. And then once we run the test, if there's a failure, we'd see a link. And if we load it in the browser, it looks like this. And so this is the page after you log in successfully. And in this instance, it caught an issue where the logout button, for some reason, is not there. And the test with the traditional assertion was actually checking to see that the notification message at the top of the page was displayed. So the test as it was written actually would have missed this issue. And so then once we discern this is actually a defect, we would reject it, save it, and then all future tests that run and use this same baseline image will know that this is not an acceptable thing, and it would fail. And if it were an acceptable thing and we accepted it, it would actually do the opposite. It would actually make all future runs know that that was an acceptable thing. So you wouldn't have to go through and update hundreds of baseline images or anything like that. So once we have that, now we can layer in access to any browser that we want. So say, for instance, we are tasked with the horrible task of testing our Selenium suite against Internet Explorer 8. Well, with Sauce Labs, that's easy to do. We just have to drop in our desired capabilities with a remote WebDriver and then configure it and point it at Sauce Labs. So with desired capabilities, we just have to set capabilities for the browser version and the platform that we want. So in this case, it's Windows XP. And then we want to pass in the name of the test. And then after we do that, we just have to create our sauce URL, which is basically a combination of our username, access key, and then the URL endpoint, which is ondemand.saucelabs.com with the correct port and the /wd/hub. And in this case, I'm actually pulling the sauce username and access key from my local system through environment variables, but you could just as easily hard code these here. After that, you just use new remote WebDriver, pass in the URL and the capabilities object, and then the rest stays the same. And then after you do that, you run your tests, you get tests in your job dashboard that look like this. They have every Selenium action, they have screenshots for each action, they have a video recapping everything for that job. And then there's additional stuff like logs and metadata. So it's really a ton of information. So if there were a failure, you could determine pretty quickly if it was legitimate or if it was actually a transient issue potentially. So I've written, as I mentioned, quite a bit about this. So here are just an initial sampling of the posts I've written about. So getting started, false positives, adding to your existing Selenium tests and incorporating it with BDD, that kind of stuff. This section is actually, you can see the long form write-up of it at this link. And if you want kind of a sense of what else is out there in terms of open source libraries and get more perspective about the ecosystem of automated visual testing, then check out that first link. And then I'd be remiss if I didn't also mention there are some Selenium Grid resources if Grid is more what you're working with and not something like Sauce Labs. So there's, of course, the write-up on how to just connect to Sauce Labs. But there are write-ups I have on connecting to a local grid that you've stood up or maintain. And then there's a great library called Selenium Grid Extras by Dima Kovalenko, who works at Groupon. That's what they use for their maintaining their massive grid. So it's a really good library worth checking out potentially if you're stuck in grid land. So the next section here is things you can do with a proxy server. Things that people probably should know. If this is a new concept to you, then this is hopefully a great takeaway. And if you're already using a proxy server, then maybe you'll pick up a couple of tips here as well. So when we have our Selenium tests, we need to connect it to a browser session, and we can have that browser connect through a proxy server. And that proxy server can act as a filter between the browser and the application that we're testing. So there's a whole litany of benefits to this that we can do. Things we can change the behavior basically of the application. We can omit things that are slow loading by blacklisting them. We can actually simulate slow internet connections. We can do a whole host of different things by using a proxy server. The most prominent proxy server that I've come across and that I've used the most consistently is BrowserMod Proxy. There's other ones, Fiddler and other ones I've heard of as well. BrowserMod Proxy seems to be kind of what practitioners and committers from the Selenium project typically gravitate towards. But your mileage may vary, and your choice may be also dependent on the programming language that you're using. So the most common immediate use case people might reach for this is for HTTP status codes. The ability to actually look up status codes for page responses or assets being loaded on the page was actively removed from the project to favor the strategy of mimicking human action. And so as a result, you have to find other ways if you want to use Selenium, which isn't really the best tool for the job, but this is one way if you were so intent on it that you could use Selenium with a proxy server to look up HTTP status codes. And so the configuration is pretty straightforward. Use a proxy server to capture the traffic from your Selenium tests. And then you can find the status code for a specific action that you're interested in, like visiting a URL. And then you can insert the status code to make sure it's what you expect. So here's an example of a test class that's using some setup and teardown with a proxy server, specifically browser mod proxy. And so I'll step through this piece by piece. So the first section here is where we're setting our field variables so that we can reuse the proxy in both our setup and our teardown and potentially in our test. And then in the setup, we create an instance of browser mod proxy and we start it. By specifying 0, it starts immediately. And then we actually create an instance of the proxy server and connect to it. And we configure it using Selenium's desired capabilities. And then we create an instance of Selenium, pass in the capabilities object. So this is how we're configuring the browser to give us a proxy session. And then we also enable the capture type so that we can get more detailed data from the HTTP archive. And things like the request and the response. So we actually get a whole host of information. So we can look at what was requested by the test action and then what was actually responded by the browser and the application rather. And then we call proxy.stop before driver.quit in our teardown. And so the test itself, we're going to do a simple lookup. There's a page on the internet where we can look up status codes. We just specify a number, and that's the response code that we'll get back. And so when we do this, what we'll get is we first have to do proxy.new har, and that actually starts capturing the HTTP archive traffic. We take our Selenium action, and then we grab the har, and then we look up the response from it. So we have to get the entries, get the first one, because we're just looking up the URL, and then we get the status from its response. And then we assert that the response is 404. And if it's not, then it would error. And it would say, expected 404, got whatever the response was instead. And then, as I mentioned, blacklisting is great because if there's slow loading resources that you don't actually care, they don't actually impact the core functionality of the feature you're testing, then you'd potentially want to remove them so that there's not going to create any sort of transient failures in your tests. And so you use a proxy server so that you can manipulate the traffic. And then you can identify third-party resources, like I said, and then make it so they don't load. It's actually pretty cool because you specify it once and then it just basically catches it before it loads. And so the way it looks in your setup is very similar, except for this one line, which is different. So you specify proxy.blacklist requests, and then you use a regular expression to identify the thing that you want, and then the status code you'd like it to return instead. And so in this case, I'm looking for a very specific URL. You can actually blacklist based on entire domains if you cared as well. And then you might, if we wanted to actually write a test to verify that this was working as we expected, you might think that we could use an approach like we just did, where we can load the page and then look through the entries and find it. But you can't actually do this approach because blacklisted entries actually skip the har filter entirely. There's actually an open issue for it. So it's something that could potentially be useful, but there's another way that we can actually test for this just to make sure that that slow loading thing is actually returning 404 instead. We can use an HTTP library, connect through the proxy, and execute that specific URL and verify that it is returning a 404 status code. And then the lesser known but pretty cool use case for a proxy server with Selenium tests is that you could actually repurpose your Selenium tests and turn them into initial load tests that you can use. So you could take your tests and use it for something like JMeter. So capture the traffic, convert the HTTP archive into a JMX file, and then run the new JMX file with JMeter to enact load on your application. Of course, you'd want to modify your JMeter setup after you do this. It's just a good starter point, but it gets you saves you a lot of ground basically. So if you have just some test, it would be very similar to what we did before, with the addition of this section here, where we're actually creating a file called test.har, putting it into the project root directory, and then that's it, just hard out right to the file that we want. And then we can open that file, copy its contents, and then paste it into something like this har to JMX converter that flood.io offers for free. And then once you do that, it'll actually download a JMX file. And then you can open up that in JMeter. And this is the link to this form here, flood.io/har to JMX. And then if you open up in JMeter, here's what an example test looks like. This one was an explicit wait test load, but this is basically it. It has all the things that were interacted with, all the assets that were loaded, and it's just a good jumping off point from here. And there's a blog post from flood.io about like some thoughts that go into record and playback of JMeter tests from Selenium, or just converting from existing tests like this, and how it's a good jumping off point, and they give some guidance around some ways that you can then optimize this for load testing and plug in additional data sets and that kind of things, additional parameters. And then one of the last kind of pieces that work into proxy server usage, and then overlaps into some other ways, is broken image checking. Aside from the obvious, just use automated visual testing and you can actually do the same thing. But if you weren't using automated visual testing, here are some different ways you can go about checking for broken images. First option is using a proxy server. The next is using an HTTP library. And the third one is using JavaScript. For a proxy server, it's very much the vanilla setup that we had before. And then the actual meat of it is here, where we do a few things differently. So we start capturing the hard traffic, and we navigate to a page. This page has broken images on it. And then what we do is we create a few different collections. We look up all of the images on the page, store it in a collection, and then we create a collection for broken images that we will use to store any broken images that we find. And then we get all the entries from assets loaded on the page. Then we loop through all the entries of all the actions. And then we also, when we're doing that, loop through all the images. And then what we can do is, for each entry, we can grab the URL and see if it equals the image source. So if an image that was loaded is the same as an image, and if that image has, or if that entry has a status code of 404. So if it is an image and it's 404, then we would toss it into this broken images collection. And when we do that, we'd actually want to get the source, so we get the URL. So what we're doing is we're creating a collection of broken images based on the URL. And then for the assertion, we create an empty collection to compare the broken images collection to. And why we want to do this is because we assume that the broken images should be empty. There shouldn't be any broken images, so the collection should be empty. But since we're comparing two different collections, we'll actually get the difference between the two. So if there were broken images, the assertion failure would look like this. It would expect an empty collection, but instead what we got was the URLs of the broken images. So now we have kind of a digest of these are the broken images on this page. And the same pattern is something we'll apply for these other options as well. So for using an HTTP library, the setup is very straightforward. It's just a simple, loading an instance of a browser with Selenium, quitting it when we're done. And then in the test itself, we load the page, create a couple collections, one for broken images, one for all the images, and then we loop through all the images on the page. The thing that's different here is that we're using HTTP client to basically use a GET request for each image URL. And then, based on its response, we get its status code and we say, if it's not 200, then we want to add the URL for it to this broken images collection. And then we use the same tactic as before. We take and create an empty collection and compare it to the broken images. And if there are broken images, we get the URLs of what they are when there's a failure. And then for JavaScript, the setup has one additional step where we're casting JavaScript executor onto the driver and storing that. So this enables us to launch JavaScript commands in the browser. And so then we use that here. Very similar setup and assertion for everything else. The main difference is we're executing JavaScript on each image, and we're making sure that we can call complete on it as if it were completely loaded, making sure that the natural width is not set to undefined, and it's making sure that it's greater than 0. So we're basically checking the size of the image and making sure it was completely loaded. And each time we call this command on this object, it will return either true or false. And so if the result is false, then we want to add it to the broken images collection. And then once we assert, we get the same output as just all the other options. Of all the 3 options, I feel like JavaScript makes the most sense since it's built into Selenium. There's no additional third-party stuff. And it's very quick. So just some food for thought. But if you're already set up with another one of these options, then they're all fine, really. Forgot password, and often forgotten about, I guess pun intended, but it's something that's not often tested because it's, you start to deal with third-party email services and latency and other kinds of things, and it can be kind of a real pain to kind of get right. But it's actually pretty straightforward. It used to be, actually I'm getting ahead of myself, the configuration. Use Selenium and you can trigger a forgot password workflow. So if you go to a page that says, I forgot my password, click a button, plug in your email, it sends the email. And you can use a real email address for this. There's a couple different service providers that you can use for this. And then you keep the browser session active. And when that's happening in the background, you can use an HTTP library or some kind of provider's SDK to retrieve the email and password information via the email provider that you're using through their API. So a lot of times it might just be a link. So you might just try and fetch a link out of an email that was received. And then you can use this password information in the active Selenium session if it's applicable. So if in this theoretical forgot password workflow, an email gets sent to you with a link that's unique, one-time use, to click to then reset a password, then this is kind of the perfect use case for that. And so it used to be that you would use Gmail for this. Gmail's easy, you get one account, and with sub-addressing with the plus symbol, you could just have infinite email accounts. But with Gmail's move to OpenAuth, it becomes a lot harder to actually write automated tests. Plus, it's technically probably most likely a breach of terms of service for Gmail. So it's not really a good option anymore. There are a couple other providers out there that are specifically designed for something like this. There's Mailosaur and Mailinator. I'm sure there's others, but these are the 2 that seem to bubble up the most commonly. And they're basically, they give you access to a mailbox, and then you can connect to it through their API. Mailinator is specifically built for public mail domains. Mailosaur is kind of more built specifically for automated testing, but both offer roughly what you're looking for. So a couple notes on this: they're not free. Mailinator has kind of like a free option, but to use their API, you have to use a paid account. Mailosaur has a free trial, and there's actually an open issue that I have with Mailosaur right now. It seems like Mailosaur is the most friendly also to get started with, and there's an open issue right now with the latest version of Selenium and the Mailosaur SDK, and so I'm actually addressing that right now with an open issue. So hopefully that gets it resolved. And then I'll publish an updated tip with a walkthrough of how to use Mailosaur. A/B testing, something very common people might run into, where people on the product team at your company potentially are introducing variants of a web application that behave differently than what your test is written for. And when that happens, it can cause your test to break. So just for a quick primer, A/B testing, split testing, It's a simple way to experiment with an application's features to see which changes lead to higher user engagement. That's why the business does this. It's a simple example would be testing variations of an email landing page to see if more people sign up. In such a split test, there would be the control, which is how the application looks and behaves now, most likely how your test is written, as it is now, and variants, 2 or 3 different changes you want to test that include changing text or element positioning, color of the submit button, potentially even just whole hog different things, which is bad news for your tests. And then once these variants are configured, they're put into rotation. So the experiment then starts, and during this experiment, each user that visits the site will see a different version of the feature. And then the engagement from that user will be tracked. And then these split tests live the length of the experiment until a winner is found, right? If tracking indicates a statistically relevant variation of higher conversions, basically, above the control. If no winner is found, new variants will be created and another experiment tried. And so if a winner is found, the feature gets updated. So this actually sounds kind of horrible for automated testing unless you're a part of the A/B testing process, but man, it's a lot of work. So it's a big whirling dervish of change that may not actually live past the initial experiment. So testing it isn't super practical. So what we can do is actually look at what an example of using a common provider like Optimizely, which is an A/B testing platform, and what it would look like to opt out of A/B tests so that you never end up in a variant. You're always in the control. And so at this link at the A/B test example on the internet, I have 3 different page states that are available. So you can identify which state you're in because there's different header text. So when you're in the control, it just says A/B test control. In variation 1, it'll say that. And then when you're not in a test, it'll just say no A/B test. So configuration is pretty straightforward. You can easily opt out of A/B tests with Optimizely by forging a cookie or appending a query to the URL. And this way you get to a known state of the page, which is not likely to change unless you're hopefully aware of it. So here's an example test where we visit the page for the A/B test, and we actually grab the header text, which is what will indicate which state we're in, and then perform an assertion. And in this case, what I'm doing is actually forging the cookie after visiting the page. So I'm loading the page, asserting that I'm actually in a test, and then I'm forging a cookie, which is the Optimizely opt-out cookie, which you set to true, and then refreshing the page, and then verifying that the header text changed. So this is really the intricate piece of this, the manage add cookie portion and refreshing the page. Alternatively, you can actually cookie before visiting the specific page, but to do that you have to first visit the application so that there is kind of a working base for cookies to be applied. So it would look like this. You would visit the page, add the cookie, and then visit the actual page that you're trying to verify. And then just the opt-out URL, very straightforward. It's just, if this is the only thing that's being appended and it's just a question mark, and then Optimizely opt-out equals true. This does trigger a JavaScript pop-up, so you do need to switch to it and then dismiss it. But other than that, that gives you the equivalent benefit, just like you would with actually forging a cookie. Okay, switching gears, file management. This is a very, very popular topic, very common, one of the first things you run into. So uploading a file. So if we have something like this, a very rudimentary file uploader where you choose a file, click upload. As soon as you click the choose file, it pops up a system dialog like this. And this is something that Selenium just can't interact with. Selenium can only work with what's in the DOM, the document object model, the actual viewport. And so what we can do, there's a couple options. One is you can actually use a GUI manipulation library like AutoIT, or you can actually input the file path directly into the form using Selenium, using the send keys. And this sidesteps the system dialog. Then you can submit the form. And then, of course, this is a much broader topic. The short answer is don't deal with file uploads and downloads. Find another way to test it. But if you have to, then these are really your 2 best options. And then it kind of gets more challenging from there once you deal with more robust kind of modern file upload and file download interactions. But for the most part, this covers a majority of use cases. So Auto-IT is not a great option just because it does limit you to a specific operating system and platform, and it's a bit heavy. So if you have the advantage to just use Selenium to inject into the form, it would look like this. So what we can do is we basically get the full path of the file we want to upload, and then visit the page, and then we just find the actual file upload input element, and then we send keys to it for the path, and then we submit, and then that's it. If you're dealing with Selenium Grid or Selenium Remote in general, you want to look into the actual file detector, which is a file uploader that sends the file across the wire to make sure that when you're running your tests on another machine remotely, it actually has the correct file. So otherwise, your tests won't work properly. Downloading file. I've written about this quite a bit. There's using Selenium and the browser to do it. And then there's doing it without that. And then there's, of course, dealing with secure files. So the two main approaches I'll cover are the first two, which you can configure Selenium to download the file to local disk and delete the file when you're done. Or you can use an HTTP library and perform a head request instead of a GET request. And what this does is it gives you the headers back for that file. And so you can check those headers for the content type and the length. So you can make sure it is the correct file type and it is not an empty file, unless you're assuming it's going to be, which is not typical. So typically it'd be greater than 0 for the length. Why would you do this, the latter option? The second option is actually favorable. It's an order of magnitude faster than using Selenium, and there's no need to actually download the file. This, of course, does not account for files that get rendered in browser memory, and when that happens, you typically have to use the first approach, which is kind of a bummer. But there is an option, at least, unless you're using Internet Explorer, which is also a bummer. But for Firefox and Chrome, it's pretty straightforward to configure the browser. So if you're just going to use Selenium, it looks kind of like this. So you have to create a new file, and in this case, I'm using a random unique ID for the file name, and then just tossing it into a directory for it. And then you have to create a Firefox profile, and you have to set some preferences. So you have to specify the download directory, and then you have to specify the folder list. There's specific numbers here. I think it's 012, and 2 denotes for you to use the file path you just specified. The other values, I think, are like if you wanted to put it on your desktop or if you wanted to use the last path that was specified. 2 is the one you want. And then you want to make sure you tell it to never ask to save to disk. And then you have to specify all the different MIME types that you want to ignore. So this gives you the ability to, when you click to download something, instead of popping up the system dialog, it's going to ignore that save to disk system dialog, only for the MIME types you specify. And then the last one, which is relevant if you're testing PDFs, you want to make sure that you disable the PDF JavaScript viewer that basically loads in a separate tab. So disable that. And then after that, it's just a matter of creating an instance of Firefox and passing in the profile object. Of course, you do want to, after your test runs, whatever you end up doing with your test, you want to delete the files in the folder. And that's it. If you did want Chrome, it's similar but different. You have to create an options object with a hash map and then do some different things like default content settings. You have to disable pop-ups. You do have to specify default directory. It's not the same. It's similar but different, basically. And then you're using a capabilities object instead of an actual profile object, but you're also using options. It's similar language, just different words. And then the end result is you create a new Chrome driver using capabilities. So that's that. The better approach when you have this option is just using an HTTP library. Setup is pretty straightforward. Just give me a browser, quit when I'm done, and then the actual test is where we're calling the HTTP library. So visit the page, and then we get the URL that we want to download. So that's the URL of the file. That's what's get returned. And then we create an instance of the HTTP library and execute a request against that URL. And then we get the header back of the content type. We get its value, and then we also get the content length back. And then we assert that the content type is the MIME type that we expect, and that the length is not 0. So that's all the kind of functional stuff for kind of hardening your tests and doing some other things that might be common. There's some additional debugging output that we can actually make our tests do. So one option is to actually be really targeted in highlighting elements. So a lot of times when you write tests, you probably, hopefully, are doing some sort of in-browser locator verification to make sure that before you write your test, that you have a locator that is going to do what you expect. What we can do is actually take that one step further and actually create a utility method that will use JavaScript to highlight a specific element. So we can actually specify an element and have Selenium highlight it in the browser so we can observe what is actually being interacted with if we cared. And so what that looks like is this. Create a simple highlight element method and make it so that we can accept an element and a duration. And so then what we do is we store the original style of that element. So we say the element that you just passed in as a parameter, want to get its attribute, get its style. And then we can take that element and apply a different style. So a 2-pixel border, solid red, it's dashed. So we're going to outline it with dashing in red. And then what we can do is keep that element highlighted for a brief amount of time, which is the time that we specify in duration. So, and we do this by using a thread.sleep. One of the very few use cases where thread.sleep is actually encouraged. And then what we do is revert it back to its original style once that duration has been reached. And so what it looks like when we actually use it's this. So if we just have a test that's exercising this functionality, we can visit a page that's actually a large nested DOM of just table data. We can actually say, I want this element, which is the sibling of the second row and the third column, and I want to highlight it to make sure it is doing, like, I have the right element or I know what I'm interacting with, and I want to highlight it for 3 seconds before reverting it back. And what it looks like is this, when you run the test and it's in the browser. So you get a dashed line of that whole element. And then taking this idea even further would be using something like growl notifications. So some of you might be familiar with growl, especially if you're using OS X. But it's basically those little pop-up messages that have information, and typically at like the top right-hand corner or bottom right-hand corner of your screen. Well, there's actually a library called jQuery growl that takes this functionality and puts it in the browser. So you can actually send little notification messages within the app. And we can actually use this to provide a lot of debugging information for our Selenium tests, so we can view it in real time with our tests as they run. So we can create something like this. This is just a rudimentary example built into a test, but you could actually abstract this into a function and then potentially use something like the abstract event listener, so it actually can be fired based on all of the different commands that are happening within Selenium. So what we can do here is a few different things. We first need to check that jQuery is on the page that we're visiting. If it's not, we need to add it, because jQuery growl, of course, needs jQuery. And then after that, we can use jQuery to add jQuery growl. And then we can add styles to the page for jQuery growl, so that it looks, pretty decent. And then once you have that, then you can just call growl with JavaScript and specify a title and a message. So if you want to do just a very kind of rudimentary, no fun style, it's just kind of gray, you just call growl, specify title and message. But if you want kind of colorized output, you can do error, growl.error, growl.notice, growl.warning, and they give you different things. And so you can say error, notice, warning, and it's very visual, very obvious. And then you specify, of course, the duration you want it to stay on the screen. And so what that looks like in practice is this. So in this case, this video is actually using the abstract event listener to fire all these events. And so then you get just this output like that. So very obvious debugging. This is what's happening as it's happening, tied to the actual video of the test as it's running. And then there's some additional Selenium resources that are available, which I've already mentioned some of them. Selenium Bootcamp, which is Java, Ruby, soon to be C#, JavaScript, and Python. It's a 5-day email course on how to get started with Selenium. And then there's the weekly Selenium tips, which are right now in Java and Ruby. Java tips will eventually be up on the website as well, but right now it's only the Ruby, but you can sign up for Java emails and eventually all the rest of the languages as well. One thing I didn't mention is that all the code for my elemental Selenium tips, it has been open sourced. And pull requests are welcome. Any pull requests I receive that I end up converting into a tip, actually writing a tip around it, you'll get a shout out. So, and I've already accepted, at least 24 different pull requests that way. And so that's really been awesome seeing the community kind of help out, and helping me bring a lot of what I've written into new languages, new programming languages. And so, and then of course Selenium Guidebook, which is kind of the thing it's kind of like if you need a full service course, that's the thing for that. But all the examples I just showed here are up and available, in addition to all the other tips that I didn't mention. And I just opened up pre-orders for the C#, Python, and JavaScript versions of Selenium Guidebook, and all of that will be released by August 1st. So you can go to seleniumguidebook.com to check that out. And if you have any questions, and feel free to submit them as part of the webinar, and then we're going to curate a handful of them and get them answered for you.